Hello, welcome to video 6b. In this video, we are going to talk about graphing and solving inequalities. I'm Mr. Miller, and I hope you're doing well today. Let's get going here. So for the first example, I just want to plot some points on the number line. So these are the numbers here we're going to plot, and let me see. The first one is -5, so I'm going to put a dot at -5. Next one is -2. We have a point at 3, a point at 7, and a point at 9. So this is an example of a discrete graph. A discrete graph is just a set of individual points like this, all right? So most of the time, though, we're going to be graphing inequalities, and their graph is a range of values. It's known as a continuous graph. So on this graph, I want to start graphing points that satisfy x is less than or equal to 4. So I can start at 4, that's the value of x that equals 4, and then I can start marking numbers that are less than 4, like 3 is less than 4, 2 is less than 4, and I could keep going, but I haven't nearly marked all of the numbers. For instance, 3.5, that would be about right here, is less than or equal to 4. 3.75, it turns out every value in between these points satisfies it also. So every number on the number line less than or equal to 4 satisfies it. Well, we're going to represent that with an arrow. So I'm going to try to do this here. It's a little bit hard for me digitally, but to graph an inequality like x is less than or equal to 4, we're going to draw an arrow. We're going to mark the point where it equals 4 if it includes that, and mark with the arrow represent every value that's less than 4. Okay, that's an example of a continuous graph. It's not individual points, it's everything from -infinity up to +4. All right. So let's practice graphing some inequalities. There's a couple steps, and once you get used to them, this is okay. We want to graph the inequality x is less than or equal to -1. The first thing we need to do is put a dot at -1. That's called the boundary point. So since it includes the equals right here, we're going to put a solid dot. That means my graph includes -1. We want values of x that are less than or equal to -1. So values that are less than -1 are to the left. So we draw a dot at the boundary point. It's called the boundary point because one side satisfies the inequality and the other side doesn't. So we put a dot there, and then we decide which way to draw an arrow, which side satisfies the inequality. Okay, well, this one says x is less than 5. That actually doesn't include 5. So what we do for this is put a hollow dot as our boundary point. All right, one side of this dot satisfies inequality, the other one doesn't. This is x is less than 5, so we're going to go to the left, because numbers that are less than 5 are to the left of 5. Okay. Let's try these. X is greater than 1. There's no equal sign here, so it doesn't include 1. We're going to put a hollow dot for our boundary point. This time, we want numbers that are greater than 1. So greater than 1 is to the right of 1. It would be all of those numbers. Any number underneath the arrow is greater than 1. Our next one is x is greater than or equal to -8. Let's put a solid dot there. And it's greater than or equal to, so to the right. Okay, that's how we graph simple inequalities. You might want to take a picture of this. This is a little reference chart. These are the 4 things that can happen, the 4 different types of inequalities. The first one is if x is greater than 2, then we're going to put a hollow dot and go to the right. If it's greater than or equal to 3, we put a solid dot and go to the right. X is less than 5, we're going to put a hollow dot and go to the left since it doesn't include 5. And x is less than or equal to 6, includes 6, so a solid dot and to the left. So these are the 4 types of simple inequalities you'd have to graph. All right, so let's do a little bit more practice. We have x is greater than or equal to -4. So it has an equals, put a solid dot at -4, and greater than is to the right. X is greater than 2. Okay, so hollow dot at 2, so it doesn't have an equals, and greater than 2 is to the right. X less than or equal to 7. So solid dot at 7, because it includes 7. Less than is to the left. X less than 0. Hollow dot at 0, and then draw an arrow to the left. Okay, sometimes we have to be careful. Sometimes inequalities are written with the variable on the right side. Well, what I suggest is reading this starting with x. If you know how to read this, then you can draw the graph. So if I start with x, x is on the smaller part of the inequality symbol. X is less than -4. It's the same as saying as -4 is greater than x, but this is a little bit useful to start with x. X is less than -4. So I'm going to put a hollow dot at -4, and since x is less than -4, it's going to go to the left. Same one with this one. Read it from the point of view of the variable. V greater than or equal to 6. So put a solid dot at 6. We want values that are greater than or equal to 6. I'm going to go to the right. All right, that was quick, but that's graphing simple inequalities. Now we want to practice writing them a little bit. So the way I do this is I put an x, and I put the number where the boundary point is, 2. Then I decide what symbol to put in there. Is it less than, greater than, less than or equal to, or greater than or equal to? Well, this one's hollow, so I know it's one of the first two. It doesn't have the equal sign. And since it's going to the left, numbers are smaller than 2, we're going to put less than. Okay, on this one, let's put x, and then the number where the boundary point is. This has a solid dot, so I know it's one of the ones with equals. We have numbers that are to the right. Those are bigger than -4, so this is greater than or equal to -4. All right, let's try this one. X, -6, it's solid, so I know it has the equals. It's going to the left, so this is less than or equal to. All right, on this one, let's put x and 5, the boundary point, and this is going to the right. It's hollow, so it doesn't have the equals. This is x greater than 5. Okay, well, we're covering a lot of things in this video, and the next thing we want to talk about is solving inequalities. They're much like equations, but there's one rule you have to remember. Maybe you've heard this. Often teachers call it the flip rule. It means that whenever you multiply or divide by a negative number, you have to flip the inequality in order for it to be true. Okay, so let's look at some examples. On this one, if I multiply both sides of the inequality by 3, on this side we get -6, and on this side we get 15, and the inequality symbol that goes between them is still less than. -2 is less than 5, -6 less than 15. So when I multiplied by a +3, I didn't have to flip the inequality. It stayed the same direction. I'm going to subtract 10 from both sides. Okay, so 27 minus 10 is 17. 43 minus 10 is 33. And inequality stays the same direction. But notice what happens when I divide both sides by -2. So I'm going to divide by -2. On the left, -8 divided by -2 is +4. And on the right, 20 divided by -2 is -10. And I notice in order to keep this true, I have to flip the inequality. That's because when we divide by a negative number, we switch which one is greater than the other. So -8 was less than 20, but when I divided by -2, +4 is greater than -10. We switched which side was larger. Same thing when we multiply. If we multiply both sides by -4, so times -4, on on this side I get negative 8, and on this side I get negative 40. Turns out negative 8 is greater than negative 40. Notice that the inequality flipped. All right, so whenever you multiply or divide by a negative number, you have to switch the sign of the inequality. It switches which side is larger. Okay, so let's see where that comes up. Now, we're going to solve this as usual. On this, if this were an equation, I'd add 81 to both sides, and I'm going to do the same thing with an inequality. I get 4x, remember this is not an equation, so bring down the inequality symbol, is less than, those two things cancel, 55 plus 81, I believe, is 136. Okay, and then we're going to divide by 4. And what I get is, I don't know, I need a calculator here. 136 divided by 4 is 34. So I don't need an equals, I need to put x is less than 34. There we go. Any number less than 34 satisfies the original inequality. So I'm going to put 34 here on the number line and put a couple numbers that surround it. And I'm going to put a hollow dot at 34 because it doesn't include 34. And we want numbers less than 34, and we're going to go that way. We're not going to worry about interval notation now. All right, let's try this one. We're going to subtract 126 on both sides. And those cancel, and I get minus 3x is greater than or equal to, well, 39 minus 126 is negative 87. All right, here's the big moment. We're going to divide by a negative number. We have to be careful here. So we get x, and on this side we get 29. We have to flip the inequality to keep it true. Right? It doesn't matter whether what we get is positive or negative. It matters what we did. We multiplied by or divided by a negative 3. So okay, I'm going to be quick about this. I'm going to put 29 here, a solid dot, and this goes to the left. I'll put in a few numbers. Okay, that's the solution, and that's the graph. All right, two more quick examples. So just like equations, we're going to add 4 to both sides. And that's a 4. And over here we get x over 17 is greater than 14. And now we're going to multiply by 17. We're multiplying by a positive number, so we don't have to flip the inequality. And we get 238. X is greater than 238. So we'll mark 238 here, and x is greater than that, so hollow dot to the right. Last one. Just like equations, when we see parentheses, we need to distribute. So negative 2x minus 14 plus 20 is greater than or equal to 36. So I can combine these two. So plus 6 is greater than or equal to 36. Subtract 6. Running out of room here. We better end this soon. You get negative 2x is greater than or equal to 30. And here we go. We're dividing by a negative, so we're going to have to flip the inequality. When I divide by negative 2, I get x. I have to flip it, less than or equal to negative 15. All right, I can put negative 15 here and still graph that. Solid dot into the left. All right, so just like equations, all those skills are going to pay off for you. Just remember, you have to flip the inequality if you multiply or divide by a negative number. All right, so here's a journal assignment for you. You can do these problems and show your teacher you understand what's going on. Good luck to you.